Find the values of m for which the line y equals mx minus 5 is a tangent to the curve y equals x squared plus 3x plus 4. So first of all, they intersect, so let's put them equal to each other. X squared plus 3x plus 4 is equal to mx minus 5. This is a quadratic, so rearrange it to make it equal to 0. X squared plus 3x minus mx plus 9 is equal to 0. And I'm going to rewrite that slightly as x squared plus 3 minus mx plus 9 equals 0. The reason I did that is to show that this is the coefficient of x in this quadratic. Now, because it's a tangent, we know that the discriminant is equal to 0 because they only intersect once. So because the discriminant is equal to 0, we get the discriminant is 3 minus m squared minus 4 times 1 times 9 is equal to 0. Expanding this, we get 9 minus 6m plus m squared minus 36 is equal to 0. Now this in itself is a quadratic equation. So now we're going to solve this quadratic equation. Let's simplify this left-hand side, m squared minus 6m, and I've got minus 36 plus 9, so that's going to be minus 27 equals 0. Now to solve this quadratic equation, I'm going to attempt to factorize it. m multiply to make minus 27, probably going to be 9 and 3, add to give minus 6, so minus 9 and plus 3. That means m is equal to 9 or negative 3. This is saying if m is equal to 9 or negative 3, then this particular line will be a tangent to this graph. Let's have a quick look at this problem in Desmos to see what happens as we manipulate it. Here I've got the graph of y equals mx minus 5, which is a straight line with gradient m. I can change the value of m, and we can see that the gradient changes, but the y-intercept stays the same at minus 5. If I now put in my graph of our quadratic, we see it's up here. Now we're looking for the value of m so that this is a tangent to that graph. So at the value of m equals 1, it's not touching the graph, the red graph, the quadratic at all. If I pull this up like this, it touches twice here and once off the top. So we're looking for the point where it's a tangent, and we can see at this point here is where it just touches once. Single point of intersection of these two graphs is where m is equal to 9. But we know from solving it algebraically there's a second point. The second point is when the graph tilts the other way. It has a negative gradient. So looking for the other time where it's a tangent, which is right there, we can see it's a tangent at this point here. It just touches the graph once when m is equal to negative 3. But Desmos is quite useful for visualizing these kinds of problems to see what is happening as that varies. We can solve this problem using this particular approach in this case. Obviously, you wouldn't be able to do that in an exam. You'd have to do it algebraically. But it's useful to use this tool to be able to see what is going on.